What's up everyone and welcome. In this episode, we are going to talk about a newly discovered ransomware gang that uses a lightning fast Python script to encrypt VMware ESXi servers. As usual, we'll run through the story and then review what we can learn from this security event, so make sure you stick around to the end.
Oh, drat these computers. They're so naughty and so complex. I could pinch them.
Researchers have discovered a new Python ransomware from an unnamed gang that's striking ESXi servers and virtual machines with what they called sniper-like speed. Sophos said on Tuesday that the ransomware is being used to compromise and encrypt VMs hosted on an ESXi hypervisor in operations that, from soup to nuts, are taking less than 3 hours to complete from initial breach to encryption. This is one of the fastest ransomware attacks Sophos has ever investigated, and it appeared to precision target the ESXi platform. Andrew Brandt, principal researcher at Sophos, was quoted as saying in a press release that accompanied his in-depth report. Brandt noted that it's rare to see Python coding language used for ransomware, but it makes sense, he explained, given that Python comes pre-installed on Linux-based systems such as ESXi, and thus makes Python-based attacks possible on these systems. While the choice of Python for ransomware is fairly distinctive, going after ESXi servers is anything but. Attackers love VMware's ESXi, formerly known as ESX, which is a bare metal hypervisor that installs easily onto servers and partitions them into multiple VMs. While that makes it easy for multiple VMs to share the same hard drive storage, it sets systems up to be one-stop shopping spots for attacks, since attackers can encrypt these centralized virtual hard drives used to store data from across the VMs. In other words, one hit locks up scads of VMs. And that's how AT&T Cybersecurity's Alien Labs explained it in July, shortly after the Revel ransomware threat actors came up with a Linux variant that likewise targeted VMware ESXi as well as its network-attached storage devices. Later that month, Hello Kitty joined the growing list of ransomware bigwigs going after the juicy target. And then, DarkSide has also targeted ESXi servers. In June, AT&T Alien Labs analyzed the Linux version of the DarkSide ransomware, which it called one of the most active ransomwares in the previous quarter. In short, everybody in ransomware land craves ESXi pawnage. It's like hitting the jackpot at the slots. ESXi servers represent an attractive target for ransomware threat actors because they can attack multiple VMs at once, where each of the VMs could be running business-critical applications or services, Brandt explained. Attacks on hypervisors can be both fast and highly disruptive. Sophos was investigating a ransomware attack when it came across the new uber-fast Python script. The attack started in the wee hours of the morning at 12:30 a.m. on a Sunday morning, when the ransomware operators broke into a TeamViewer account belonging to a user who had admin access, but who didn't have multi-factor authentication enabled. Here's a timeline of what happened. At 12:40 a.m., just 10 minutes in, the attackers were looking for network targets using the advanced IP scanner tool for reconnaissance. Sophos' investigators believe that the network's ESXi server was vulnerable because it had an active shell that an IT team was using for commands and updates. According to Sophos' report, ESXi servers have a built-in SSH service called the ESXi shell that administrators can enable, but which is typically disabled by default. This organization's IT staff was accustomed to using the ESXi shell to manage the server. So this team was accustomed to using it to manage their servers, and they had enabled and disabled the shell multiple times in the month prior to the attack. So in theory, they were doing the right thing. They were enabling it when they needed it, and they were disabling when they don't need it. However, the last time they enabled the shell, they failed to disable it afterwards. So there's no automatic mechanism to disable it, let's say after 2 hours of non-use or inactivity on the system, or even 15 minutes of inactivity from a particular user on the system. Now, the criminals took advantage of this fortuitous situation when they found the shell was active.
Why did I do it?
At 2 a.m., the attackers downloaded an SSH client called Bitwise and used it to log into a VMware ESXi server that they identified using advanced IP scanner. 3:30 a.m., 3 hours after the attacker scanned the network, they used the pilfered admin credentials to log into the ESXi shell. Then they copied a file named seker.py to the ESXi data store, which houses the virtual disk images used by the VMs that run on the hypervisor. The Python script uses the vim-cmd command functions of the ESXi shell to produce a list of the names of all VMs installed on the server. Then it shuts them all down, he said. Only after the VMs are all powered off will the script begin encrypting the data store volumes. Then, the Python script slithers through, picking up off VMs one after another, Brandt recounted. One by one, the attackers executed the Python script, passing the path to data store disk volumes as an argument to the script. Each individual volume contained the virtual disk and VM settings files for multiple virtual machines. The ransomware snippet uses just a single instruction for each file it encrypts, invoking the open source tool OpenSSL to encrypt the files with the command here. Sophos investigators managed to nab a copy of the Python script, in spite of the attackers having apparently overwritten it with other data before deleting the file. The other data, meaning specifically the curse word FUC, you know the rest. Finally, it deletes the files that contain the directory listings, the names of the VMs, and itself by overwriting those files before deleting them, Brandt wrote. Weighing in at only 6 kilobytes, it's an itty-bitty thing that can do a whole lot of damage. The script contains variables that the attacker can configure with multiple encryption keys, email addresses, and where they can customize the file suffix that gets appended to the encrypted files, Brandt wrote. Specifically, the Python script embeds as variables the file suffix it appends to encrypted files and email addresses to be used to contact the attacker for payment of the ransom. It also embeds the ransom note text. Now, while walking through the code, Sophos investigators noted multiple hard-coded encryption keys, as well as a routine for generating even more encryption key pairs. They found that odd, Brandt said. Normally, an attacker would only need to embed the public key that the attacker generated on their own machine, and would be used to encrypt files on the targeted computers, he noted. But this ransomware appears to create a unique key every time it is run. It turned out the attackers executed the script once for each ESXi data store they wanted to encrypt. Each time it executed, the script generated a unique key pair to use in encrypting files. In the case that Sophos investigated, the attackers targeted 3 data stores, each time with individual executions of the script, so the script created 3 unique key pairs, one for each data store. Those keys weren't going anywhere, though, given that the script had no ability to transmit them to, let's say, a command and control server. But the attackers obviously didn't want to leave them sitting around where the victims could use them to decrypt their locked files without paying a dime in ransom, so the script wrote out a copy of the secret key, then encrypts it using the embedded hard-coded public key. While Linux variants of malware that can be used to target systems such as ESXi are still relatively uncommon, endpoint protection on these kinds of servers is even rarer, Brandt said. He passed on advice for hardening ESXi on other hypervisors, including standard security best practices such as avoiding password reuse, using complex, difficult to brute force passwords of adequate length, enabling the use of MFA wherever possible, and enforcing it for accounts with high permissions such as those of domain administrators, and shutting off shell when it's not in use. VMware has also published a list of best practices for administrators of their ESXi hypervisors on how to secure them and limit the attack surface on the hypervisor itself. So, what did we learn? Again, we see the dangers of remote control software like SSH, RDP, TeamViewer, among a ton of others. These services are not meant to be on 24/7 or accessible by the entire world. We as IT professionals need to implement better security for these services, including a mostly off-based usage principle. This is not that easy for, let's say, cloud-based systems, but combining a firewall lockdown IP rule set along with creative solutions can ensure we have the best security possible. Now, in the coming weeks, I will share a 100% proven method for securing these services, so make sure you subscribe to my channel and smash the bell to be alerted when I upload new episodes, specifically the Securing Remote Control Software episode. What else did we learn? Secure passwords. This hack, as reported, was enabled by one of the admins, or one of the people having admin access, not using multi-factor authentication. For critical services, this is an absolute must. This story is a prime example that shows how important it is. With implementing just 2 security policies, the Mosly off principle for remote control software and MFA, or multi-factor authentication, this entire ransomware attack would not even be possible. With that, I say thanks again for watching. Don't forget to share and subscribe if you haven't already, and smash the bell if you haven't already, and I will see you on the next episode. Take care.